Are you ready for 6 new formulas? No? How about 5? No? How about 4? Oh, okay, 4 will do? Great. So instead of 6, we'll do 4. You don't have to memorize the bottom 2. If 4 is too much, well, that's just too bad. Okay, I'm going to use this top example to show you where one of the formulas comes from, and then I'm going to just give you the rest of them. So let f equals tangent of x, find the derivative of the inverse of x, just of x. It doesn't have to be at a specific x value. Basically, we're going to find, this is going to be wordy, we're going to find the formula for the derivative of the inverse of tan, and that actually is showing up right here. Now, what's arctan? Okay, just to be clear, and this is going to just be kind of subtle and written in pencil in the corner. I'll put it in this corner. The sine of x, like inverse sine of x. If you were finding the measurement of an angle, that is also called arcsine of x. And then we'll do the same thing with tangent. So the inverse tangent is equal to arctangent. You get my drift. I'm not going to write that for all 6 of them, but this is a different way of writing it, and this is, x. This is what we're going to do in calculus more so than this. All right. F equals tangent of x, find f inverse prime of x. What in the world? Let's just start writing a whole bunch of stuff, okay? I'm just writing things. Here goes. I know the derivative of tangent. Yay, good for me. The derivative of tangent is, do you remember it? Secant squared. Well, also the inverse of tangent is basically, instead of plugging in an angle, it gives you an output of an angle when giving you the ratio of the opposite and adjacent. As wordy. Anyway, the inverse of a tangent, we used to write it like this, now we write it like this. Either one will do. I'm going to go with the arc stuff. Arctan. There we go. So I've just written a couple things down, and I'm also going to use this little formula that we learned in the last lesson, where we are finding the derivative of an inverse. Okay, now in the formula that you got in your notes, it had f's and g's. We're dealing with f and f inverse in this case, so f prime. And here was a g, but that g represented the inverse. There we go. And what I'm going to do is just start plugging some stuff up and cleaning up a formula that will eventually pop up right here, okay? And then, like I said, I'll just give you the rest of them. This is fun. You're going to love this. So we have 1 over, well, f prime, well, that would be secant squared. Secant squared of f inverse. Well, f inverse is arctan. Okay, arctangent of x. So this is where we're sitting right now. And I'm looking at this and I'm saying, well, I'm not sure what I can do with that. And so my mind just goes back and I start daydreaming and I'm thinking back to some old stuff. And if your mind doesn't go there, that's fine. But hopefully at some point, if you were to take a nap long enough, you would think back to our Pythagorean triples. And here's one of them. Secant squared is equal to 1 plus tangent squared. For the sake of simplifying, I'm going to turn this around. I'm going to make it 1 plus tan squared instead of tangent squared plus 1. So 1 plus tangent squared. So instead of secant, I'm going to have 1 plus tangent squared of our input, and our input is arctan. All one word, although I put a little gap in there. And at this point, I see tan and arctan. So if this is the fun little thing about inverses, if I plug in the inverse into the original function, I get what I had to start with. So if I was to say to you, hey, look, I have a scrap piece of paper, and I want to know what the tangent of the arctangent of, I'm making this up, arctangent of 1/2 is, okay? If I wanted to know that, got carried away with my parentheses there, then I could be like, oh, the arctangent of 1/2, and I get that, and then I find, no, these are inverses. They cancel out. You get 1/2, all right? If I was to square that entire operation, then I don't just get x, I'd get x squared. There you go. So the derivative of the inverse of tangent, let me rephrase that, the derivative of arctangent, that's what you just found, is 1 over 1 plus x squared. So I'm going to write one more little line right here, And so this is a fancy way of saying I really want to know the derivative of arc tangent. And I end up with that. Okay.